So basically what we're doing here is just using Pythagorean theorem to solve for a missing link. In the past, you guys have been able to give decimal answers, which was cool, like 11 point something, but today I'm asking you to give a radical answer. So I think this is going to be the part where most of us experience discomfort today, is simplifying the radical. All right, so let's move on to the next one. Is it a right triangle?
Yes.
Do I have 3 side lengths listed?
No. Yes.
Yes. 6, the square root of 85, and y. There's 3 of them there. Yeah, they're not numbers, but they're all listed. So in this scenario, we have to use Pythagorean theorem. So basically, if you understand what's going on, a squared plus b squared equals c squared. That's basically, you can do algebra from there. I'm asking you as a pre-AP student to get to this part. Oops. Now, pre-AP, you're like, ooh, that's gross. The square root of the square root of 85 squared minus 6 squared. Hey guys, they do the exact same thing. Right now, the radical is just holding your math. The square root of 85 squared. 85. Squared and radical will always cancel each other out. So the square root of 85 squared, 85. Minus 6 squared, 36. Compute mathematics, 85 minus 36. Huh? 49? For sure?
Yes.
Perfect, I trust your calculator. And now we have to simplify the radical. What is the square root of 49? What's that? 7. Done. It's a nice whole number.
Are they always going to be that nice?
No.
So in this part, the trade-off was nasty number here, pretty number here. So it kind of depends. On your test, no guarantees. For some of you guys that have already taken the extra credit, give me my 9 points back, 2 square roots of 29. Ooh. And you had to operate with 6 square roots of 3 and 9 square roots of 3 and 12 square roots of 3, and you had to operate with those. Good luck. If you want 9 points, gotta earn them. Oh, here we go. It's what? What? There is no right side up, upside down in geometry. It's just not the way you're used to seeing it. So this tricks the regular kids because they're like, oh, I'm missing C.
No.
I always use the right angle to point to my hypotenuse. I know I'm missing a leg. So pre-AP says y equals pre-AP.
61 squared minus 11 squared. I was like, who's pre-AP?
Huh? I don't know. Ask your calculator.
37.
I knew that. 3,600.
I remember my first time reading a number out loud. 3,600.
So the square
Oh,
root of 60.
man, that was rough.
So this question mark or statement?
Statement.
The square root of 3,600 or 3,600.
60.
Y equals 60. Yay, nice number. That is known as an uncommon Pythagorean triple.
What?
What? An uncommon Pythagorean. Teachers are lazy.
Fact.
Facts.
Yeah.
And especially in mathematics, if I want to give you a nice whole number, I'm going to use a Pythagorean triple or a multiple of that Pythagorean triple. See if this works. Do you think that a squared plus b squared equals c squared? Watch. Is a squared plus b squared the same thing as c squared? That's an uncommon Pythagorean triple. And what I did is I just multiplied all these numbers by 2 and got the same Pythagorean triple. Teachers are lazy. So you'll see a lot of 3, 4, 5, 6, 8, 10, 9, 12, 15 because they're all multiples of a very common Pythagorean triple. Alright? We'll get there in a little bit. That's if I want a whole number back. If I don't want a whole number back, I'll give you something like this.
Thanks.
You're welcome.
So what are we missing? A, B, or C?
B.
Or A, doesn't matter. X is equal to the hypotenuse squared minus the leg squared. So you gotta try and compute 18 squared minus 16.
How's calculator?
324 minus 16.
Bless you.
Thank you.
Minus. Do a little bit of subtraction.
277.
Now, what?
Yeah. I got like 2 square root of
2 square roots of 77.
Yeah.
Can I show everybody the rapid way, the take my brain out of the method way to do this?
Please.
So people like this method, which I think takes forever.
Oh, the dividing method?
Right.
I do that all the time.
But here's what I'm talking about. This is what people tend to do. New page. That's 2 keystrokes. Add a graph. 3. We did 4, 5, 6, 7, 8. Right? 308 divided by x. That's 8 keystrokes. Enter. 9. Control T. 10, 11. So I type 308 divided by x in my calculator. I go to find a table, 11 keystrokes later. Now I'm looking for the first perfect square to pop up. I got 4 and 77. That is a perfect square. 4 is a perfect square, 77 is not. So here's where we're at right now. This is the same thing as 4 times 77. Can you take the square root of 4? Yes. Can you take the square root of 77? No. X equals 2 square roots of 77. Is that how you did it?
I was taught that way.
That's how you were taught? So I prefer this method. It's a little quicker, not necessarily easier to understand. I just take my number divided by 2. Not a perfect square.
Divided by 3.
No. Well, boom. Right? So divide by 1, 2, 3, 4, which 4 is a perfect square, 77 is not. Sometimes it happens quick, sometimes it doesn't happen very, very fast.
No.
It's either way, it's guess or check. So, I mean, this is a lot of keystrokes too. We're already at like 14 or 15 there. It's whatever you like best.
I don't like that graph.
You don't like the graph made? You don't like that?
I do that.
You do this,
Oh,
or you do the graph?
yeah. I used to do that.
Chocolate or vanilla, Blake?
Dude. Swirl.
this way
Oh my god.
or this way?
I don't know. We'll figure it out.
Which way have you done? Which way were you taught?
I was taught the divide way.
This way.
No.
No.
This way.
Yeah.
Yeah.
that
Blake
way.
was taught this
Yeah.
method. Blake was not taught this method.
Yeah.
Both methods work. Oh, baby Jesus, Blake. People on YouTube are like, what is he talking about? All right.
Okay.
64.
So are we missing a leg or a hypotenuse?
Hypotenuse.
So this is a squared plus b squared equals c squared. Or the square root of a squared plus b squared equals c squared. So when we're solving for a hypotenuse, you add under the radical. When you're solving for a leg, you subtract under the radical.
Oh, this was on our homework. 128 popped up a lot. So did like
7, 16? No. What? No. We're done.
Yeah.
Yes. How did you do that?
Man, y'all do this math way
Hey,
too quick.
Hey, how many 64s do we have?
64 times
We have 2 64s.
Oh,
Yeah or no?
yeah.
So how do I write that?
That's a great question.
2 times
2
64?
64s. 2 times 64 is the same thing as 64 plus 64. What is the square root of 64?
8.
8.
That's
There will be a time in your life where you see a triangle like that and you're not allowed to use a calculator.
why.
Because it's another part of geometry. So here's what the answer is. Notice how the question is presented. 2 numbers with 1 missing variable. Now I can do this. That is a right triangle, right?
Yeah.
Everything right triangle. But specifically, it's an isosceles right triangle. The base angles theorem.
Yeah. Oh, I see. X equals 7, so then you do the math.
No, and then you just multiply by the square root of 2.
Multiply by the square root of 2.
It's a 45, 45, 90 triangle. It is so special, they even put it on your formula chart. All day tomorrow we'll be doing that. Yay, math. Alright, I'm going to skip this one. The converse of the Pythagorean theorem. So, this is talking about Pythagorean theorem still, but it's what else does it tell us? So 2 things can happen. If c squared is bigger than a squared plus b squared, it's obtuse. Because c is bigger, it's more than 90. If c squared is less than a squared plus b squared, it's acute. So if it's bigger than a squared and b squared, it's a big angle obtuse. If c squared is smaller than a squared and b squared, it's a little angle, it's acute. Okay? So this one's not solving for anything. You have to have all 3 numbers. You just have to make sure you're using the right letters in the right areas, the right number for the right assignment. So the big thing here is which one is C?
10.
10 squared is what?
100.
100. Now we have to figure out what is 3 squared plus 8 squared. Your calculator can do that for you. You can do it in your head. 3 squared plus 8 squared. We're just trying to be rapid with our math. 73. Is 73 bigger or smaller? So if C is bigger,
It's obtuse.
it's obtuse. So the answer to this question is, now the reason you're confused is because in your notes it's presented like this. It's presented backwards. They write C first.
It's the one that.
What?
I'm gonna say something else.
So which one's the biggest number here?
7.
What is 7 squared?
49.
40.
And then 25 plus 16?
40.
41 bigger or smaller than 49?
Smaller.
So because 49 is bigger, what kind of triangle is it?
Obtuse.
Obtuse.
Same. Are you
It's always good to know what you're doing. I wrote it backwards because that's what I was reading in the notes. Careful. Acute?
Yes.
144 plus 225.
369.
Was it 369 for these?
Yeah.
What's this one?
361.
How do you do that, man?
With the calculator.
Oh.
So because c squared is smaller than a squared and b squared, acute. How y'all feel about that? So the biggest way to make a mistake here is if you forget how it's supposed to be set up. Alright? Make sure you're justifying it the right way. What? This one? It's a right. Are you using this as C? I know this is a right triangle because a squared plus b squared equals c squared, and that is Pythagorean theorem. There's also a common Pythagorean triple, 5, 12, 13.
Yeah.
What's 5 times 2?
10.
What's 12 times 2?
24.
What's 13 times 2?
26.
Common Pythagorean triple. That's why we just left similarity. It's the scale factor of 2. Everything still applies. All right, here we go. Pythagorean triples.
Oh, man.
It would be really wise to memorize these 4. That's why they're on your paper. Yes, they'll be disguised all over your test. Is this a Pythagorean triple?
No.
Is what I just wrote a Pythagorean triple? The answer is no, it's not, but it is a derivative of a Pythagorean triple. So if you read the definition, it says a Pythagorean triple is 3 whole numbers. 3, 4, 5, Pythagorean triple. But if I divide 3, 4, and 5 by 2, I get this same Pythagorean triple. It will work. It is a right triangle. So Pythagorean triples always work. 3 squared plus 4 squared, 5 squared. They are equivalent. Right? And then derivatives of Pythagorean
I
triples.
think you messed up. You did multiply.
Yeah.
Plus.
144 does not equal 25.
They are Pythagorean triples. All the derivatives of Pythagorean triples are the same. 1.5 squared plus 2 squared. And if I do half of 5, which is 2.5 squared, it also works. Teachers are lazy. They take common Pythagorean triples and manipulate them so you get answers that work. Otherwise, I can get some really nasty decimals. So the last portion of this, hey YouTube, is what is the other number? What is the third number that makes a Pythagorean triple? Remember, Pythagorean triples have to be 3 whole numbers. So think about this before you go crazy. Is it smaller or is it bigger? Did you realize that was an option? That your third number could be smaller than 13 or it could be bigger than 84. So how do you do this?
Couldn't it be in the middle too? No, you couldn't.
It could be in the middle. So it's either smaller than 84 or it's bigger than 84. We're either missing a hypotenuse or we're missing a leg. So two ways you can do this. So I showed you this way earlier. You could be missing C. If you just slam that in the calculator, missing C, and it returns a whole number, you're done. The square root of 13 squared plus 84 squared. Hey, 85. Boom, I'm done. What's the third number? 85. If you thought you were missing a leg, you would have done something like this. Decimal, no good.
It's just trial and
It is, that's all there is, trial and error. Okay, trial and error until you get a whole number. What do you think? 36? It is 36?
Because it's just like a multiplied by 2 of the 5, 12, 13, or multiplied by 3 of the 5, 12, 13.
Okay, so you're saying the answer is 36? So this should work. Because we're missing a leg, right? Boom, 36, you're right. So you can know what the Pythagorean triples are and try and find derivatives of them, or you can just math it. It's all like you guys going crazy. So look, we talked about really two things today. If I give you a triangle, can you find the third side? Whatever that third side might be. And then what the Pythagorean theorem converse means as far as acute or obtuse. So I'm going to leave you with this. Boom. Get your book out and see what you can get done. Practice assignment, right? I'm not taking this for a grade. It's just a point in time for you to practice your math. Practice assignment. I don't care if you do all of it. I don't care if you do a few questions. Practice. Whatever you feel the most uncomfortable with, practice it. No, that's past due.